Okay, so hello students, I hope all of you are doing perfectly well. In today's class, we're going to be solving the problems on center of mass, but of course in two different frames. एक बार एक क्वेश्चंस को हम सारे सेंटर ऑफ मास फ्रेम में करेंगे और एक बार सारे क्वेश्चंस को हम लोग ग्राउंड फ्रेम में करेंगे. तो जो भी बच्चे क्लास में ज्वाइन हो रहे हो वो बच्चे सारे एक बार कमेंट सेक्शन में मुझे बता दें कि इफ यू ऑल कैन सी माय स्क्रीन प्रॉपर्ली एंड हियर माय वॉइस प्रॉपर्ली और नॉट. इफ यू कैन देन विदाउट एनी फर्दर ड्यू वी कैन इनिशिएट द क्लास. तो जल्द से जल्द सारे के सारे बच्चे एक बार टेक्स्ट कर दे तो हम लोग फिर से शुरू कर सकते हैं. देखो सबसे पहला क्वेश्चन तुम लोग के सामने स्क्रीन पे है. तो सबसे पहले हम लोग जो मेथड यूज करेंगे ये है ग्राउंड मेथड, ग्राउंड फ्रेम मेथड एंड देन सेंटर ऑफ मास फ्रेम मेथड. तो पहले है मेथड 1. यहाँ पे नहीं लिखते हैं, यहाँ पे लिखते हैं मेथड 1, that is ground frame method. Ground frame method. Achha, let me tell you, there is no external force on the horizontal direction, so linear momentum should be conserved along the horizontal direction. No external force along horizontal direction, and therefore we can say linear momentum initial should be linear momentum final. मैक्सिमम कंप्रेशन स्प्रिंग में जब होगा तब दोनों सेम वेलोसिटी से मूव करें. At maximum compression of the spring, both block will move with common velocity suppose capital V, full stop. Therefore I can write m1 v naught is equals to m1 plus m2 into v, जहां से v का वैल्यू आ रहा है m1 v naught divided by m1 plus m2. Again वर्क एंड काइनेटिक एनर्जी थ्योरम अगर अप्लाई करूं तो व्हाट कैन आई से, यूजिंग कंजर्वेशन ऑफ मैकेनिकल एनर्जी, बाहर से कोई फोर्स नहीं है तो वर्क एक्सटर्नल प्लस वर्क इंटरनल इज चेंज इन काइनेटिक एनर्जी. यहाँ पे इंटरनल वर्क डन तो है, वर्क by external force plus work by internal force is equals to change in kinetic energy. ऐसे कर सकते हो, is equal to change in kinetic energy. जरा बताओ वर्क डन बाय द एक्सटर्नल फोर्स कितना, एक्सटर्नल फोर्स के द्वारा वर्क डन 0 है, प्लस व्हाट इज वर्क डन बाय द इंटरनल फोर्स के द्वारा वर्क डन है सर स्प्रिंग में कंप्रेशन हो रहा है तो माइनस हाफ के एक्स स्क्वायर. That is change in final kinetic energy is half mv square m1 plus m2 into v square minus initial kinetic energy is half m1 v naught square. मैं थोड़ा सा मेरा वीडियो ऑफ कर देता हूँ ताकि आप लोगों को दिखे अच्छे से. As you all can see, minus half kx square can be written as half m1 plus m2 v square minus half m1 v naught square. Putting the value of v over here, we can get the value of x. This is equation number 1. This is equation number 2. Solving 1 and 2. हमें क्या मिल रहा है? X is root over of m1 into divided by m plus m2 into k रूट ओवर ऑफ m1 m2 डिवाइडेड बाय m1 प्लस m2 इंटू k, यहाँ पे तुम्हारा बाहर में है v नॉट, v नॉट इंटू दिस, दैट्स द आंसर। ये था पहला मेथड से। दूसरा मेथड है सेंटर ऑफ मास फ्रेम मेथड 2, जिसको हम कहते हैं वर्क एनर्जी थ्योरम फ्रॉम सेंटर ऑफ मास फ्रेम। वर्क एनर्जी थ्योरम फ्रॉम सेंटर ऑफ मास फ्रेम। तो भाई साहब ये फॉर्मूला आता है वर्क डन बाय एक्सटर्नल फोर्स प्लस वर्क डन बाय इंटरनल फोर्स should be equals to kinetic energy final with respect to center of mass minus kinetic energy initial with respect to center of mass। अच्छा एक बार जरा देखना, फाइनल काइनेटिक एनर्जी के एफ विद रिस्पेक्ट टू सेंटर ऑफ मास हो जाएगा, दोनों सेम ही वेलोसिटी से मूव कर रहे हैं, तो हाफ म्यू v माइनस v स्क्वायर। इनिशियल काइनेटिक एनर्जी विद रिस्पेक्ट टू सेंटर ऑफ मास हो जाएगा हाफ म्यू, एक का वेलोसिटी v नॉट है, दूसरे का वेलोसिटी 0 तो v नॉट माइनस 0 स्क्वायर, that is half mu v naught square। हो गया। अच्छा यहाँ पे एक्सटर्नल फोर्स नहीं है, तो वर्क डन बाय द एक्सटर्नल फोर्स विल बी 0, बट ऑफ कोर्स इंटरनल फोर्स है, तो minus half kx square is actually equal to kinetic energy final is 0 minus kinetic energy initial is half mu v naught square, जहाँ पे mu is your m1 m2 divided by m1 plus m2। गुड। तो यहाँ से सॉल्व करके बड़ी ही आसान से तुम प्रूव कर सकते हो कि ये चीज तुम्हारा आ जाएगा, माइनस माइनस कैंसिल, हाफ ऑफ कैंसिल, x इज इक्वल्स टू म्यू v नॉट स्क्वायर बाई k का रूट ओवर, x इज इक्वल्स टू v नॉट इनटू रूट ओवर ऑफ म्यू बाई k। v नॉट इनटू रूट ओवर ऑफ म्यू बाई k। ठीक है। नाउ एक दूसरा क्वेश्चन हम लोग कर सकते हैं। जो क्वेश्चन ये है, बोला गया है ब्लॉक ऑफ मास m is pushed with a velocity v naught along the surface of a trolley car of mass m, then the horizontal ground is smooth and the coefficient of friction between the block and the plank is mu. Find the minimum distance between the relative sliding the block and the plank। minimum distance of relative sliding between the block and the plank। good। तो कैसे करेंगे? हॉरिजॉन्टल डायरेक्शन में कोई एक्सटर्नल फोर्स नहीं है, तो लिनियर मोमेंटम शुड बी कांस्टेंट। there is no external force along the horizontal direction, no external force, on horizontal direction, on no external force in horizontal direction on block plank system। तो linear momentum should be constant, so pi equals to pf half small m v naught square is equals to m into v naught is equals to small m plus capital M into v, जहां से v का वैल्यू आ रहा है m v naught by small m plus capital M। Then work done by external force plus work done by internal force is equals to change in kinetic energy final minus kinetic energy initial. Work done by external force is 0, but work done by internal force is due to the friction. अगर ये x distance move कर रहा है on the block, on the plank, if it has moved distance x on the plank, तो minus fx frictional force from the ground is equal to ground from इसने x distance move करा है is equal to kinetic energy final minus kinetic energy initial, तो half mv square minus half, अच्छा यहाँ पे स्मॉल m प्लस कैपिटल m होगा, स्मॉल m v नॉट स्क्वायर होगा, f is equals to mu mg minus mu mg is the frictional force from ground frame of reference. If it has moved in a distance of x, so work done by the frictional force is minus mu mg into x. Done. दोनों के बीच में अगर रिलेटिव स्लाइडिंग x हुआ है तो of course from solving 1 and 2, this is equation number 1, this is equation number 2, just v का वैल्यू यहाँ पे पुट कर दो, solving 1 and 2 हमें x मिल जाएगा v नॉट स्क्वायर बाई 2 1 plus small m by capital M mu g. Done. इसी क्वेश्चन को हम लोग दूसरे तरीके से भी कर सकते हैं, मेथड 1, मेथड 1, इसको दूसरे तरीके से भी कर सकते हो, मेथड 2, that is work done by external plus work done by internal is actually equals to kinetic energy of the system with respect to center of mass, center of mass minus kinetic energy of the system initially with respect to center of mass. Okay, what is the final kinetic energy with respect to center of mass? So both has the same velocity, so half final kinetic energy is equals to mu relative velocity v minus v ka square, that is 0. Kinetic energy of the system initially, relative velocity is v naught, so half mu v naught minus 0 square. From here I can write work done by the external force is 0, work done by internal force is minus mu mg into x, kinetic energy final is 0, negative kinetic energy initial is, what can I say, half mu v naught square, half mu v naught square. जहाँ से I can write this minus minus will cancel out, x is equals to, नहीं mu also will get cancelled out, mu by 2, अच्छा नहीं minus mu cancel out, m से नीचे चला जाएगा, v naught square by 2, Okay, there are two things we need to consider. First one is frictional coefficient. Second one is reduced mass. We both represent these things by mu, but we have to change a little bit here. So this thing, it will be actually equals to half m1 into hang on. If I just take the coefficient of friction as okay, I can just do a little bit of change here, no issues. m1 plus m2 v minus v square, that is 0. Half m1 m2 divided by m1 plus m2 into v naught minus 0 square, that is half m1 m2 divided by m1 plus m2 into v naught square. Done. So you just put it here, m1 m2 divided by m1 plus m2 into v naught square. So one has a mass small m, another has a mass capital M. बेहतर होगा अगर हम लोग स्मॉल m कैपिटल में लिखे ये चीज. Small m capital M by small m plus capital M. We can write it like this. Here it is small f, it is the frictional force. Is this, and this thing will become equals to x is equals to v naught square by 2 1 plus small m by capital M into mu g. Yeah, I think now it's clear. Now there is another question that says this. क्या बोला गया सवाल में? बोलेगा block of mass m1 is projected with a velocity v naught so that it climbs onto the smooth wedge of mass m2 if the block does not level the wedge, does not leave the wedge होगा ये, does not leave the wedge. So then find the maximum height attained by the block. Good. जब block maximum height attain कर जाएगा, so in that case block and wedge will move with a common velocity. तो m1 v naught plus 0 is equals to m1 plus m2 into some common velocity v. From here v is equals to m1 v naught by m1 plus m2. This is first equation. There is no force along the horizontal direction. Apart from that, work external plus work internal equals to kinetic energy final minus kinetic energy initial. External work is because of the work due to the gravitational force, which is minus mg. What is the height of this? m1g h. Then plus work done by the internal force is 0, which is actually equals to kinetic energy final minus kinetic energy initial. What is the kinetic energy final? Half mv square. It is initial half. No, final kinetic energy is half m1 plus m2 into v square minus half m1 v naught square. Done. एक बार देख लो, ये थिंग आई थिंक क्लियर है. माइनस एम जी एच इज इक्वल्स टू हाफ m1 प्लस m2 into v square minus m1 v naught square by 2. Good. This is my equation number 2. Now you can solve this two equation and tell me the answer. Solving 1 and 2. We get h is equal to v naught square divided by 2 into 1 plus m of the m into g. Done. That's all. This is method 1. Here with respect to ground frame. But I can tell you the same problem in method 2 as well. Method 2. With respect to the what frame? Center of mass frame. So work external plus work internal equals to kinetic energy final with respect to center of mass minus kinetic energy initial with respect to center of mass. Done. Well, kinetic energy final with respect to center of mass is equals to half mu into v relative, v minus v square, that is 0. Kinetic energy initial with respect to center of mass is half mu v naught minus 0 square, that is half mu v naught square. What is the work done by the external force, that is gravity, minus mgx m1gx plus work done by internal force is 0, that is actually equals to ये वाला 0 है minus ये वाला तुम्हारा है half mu v naught square. So from there I'm getting x is actually equals to mu v naught square by 2m1 into g. Yeah, that can be written as v naught square by 2 1 plus m1 into by g into g. That's all. So all these questions are good. There is another question which I would like to just take it and add it here. A small block of mass m is projected on a long plank of mass 3m with a velocity v naught. Let me just take this question. I got the question, but the figure is not appropriate. The question looks like this. Okay, I hope all of you can see the question. The question says a mass m is projected over a rough long plank of mass 3m kept on a smooth horizontal surface. Find the work done by the friction till the relative sleeping stops. Okay. If the relative sleeping stops, then both of will move by the same velocity. When relative sleeping stops, then both will move with a common velocity v naught. Capital V, then I can just write down small m v naught is small m plus 3m into capital V, from which I get capital V is v naught by 4. Apart from that, work done by external plus work done by internal equals to kinetic energy final minus kinetic energy initial. Well, I don't see an external force which is doing work, so it's 0. The internal force is there, there's a friction. This plank is actually rough, so frictional force will do a work upon this minus what I'm gonna get work done by friction. That should equal to kinetic energy final is kinetic energy final is half mv square minus kinetic energy initial is half m plus 3m into v square minus half m into v naught square. That implies work done by the frictional forces. See, 4m by 2, that's 2m. V square means v naught square by 16 minus mv naught square divided by 2. Can take common mv naught square. 1 by 8 minus 1 by 2. So minus 3mv naught square by 8 minus 3mv naught square by 8. Minus 3mv naught square by 8. That's what I'm going to get. You can also do this question on the by method 2 also. And also do this question by method 2. This is method 1. You can also solve this question by method 2, which can be done work done by external plus work done by internal is kinetic energy final for center of mass, kinetic energy initial for center of mass. Final will be 0, initial will be half mu v naught square. This thing is 0 plus work done by friction. Work done by friction is minus half mu v naught square. What is mu? 3m into m divided by 3m plus m, so 4m. 3m by 4, so 3m v naught square by 8. Again negative sign. What's your mu? Mu is 3m square by 3m plus m. Three m by 4. That's all. So we can solve this question in both ways. Then there is another question that can be stated as figures show a block A of mass 9m having a smooth semicircular groove of radius capital R placed on a smooth horizontal surface. Okay. Sorry. So the question looks like this. Let's solve this question. What does it represent? Figure shows the block A of mass 8m having a smooth semicircular groove of radius A placed on a smooth vertical surface, horizontal surface. Okay. The block B of mass small m is released from the position in the groove where the radius is horizontal. Speed of the block A when the block B reaches the bottom. They want to know what's the speed of the block A when the block B reaches the bottom. Okay. Suppose V1 be the velocity of the block with respect to A. Towards right. V2 be the velocity of A towards left. This question can be solved like this. When B reaches the bottommost point, then V1 be velocity of A towards left, velocity of A towards left, V2 velocity of B with respect to A towards right, then velocity of A with respect to ground, velocity of A with respect to B is velocity of A with respect to ground, and the velocity of B with respect to ground. Meaning velocity of B with respect to A. We know that velocity of B with respect to A is velocity of B with respect to ground minus velocity of A with respect to ground. So V2 Here B with respect to ground, I don't know. I need to find out. A with respect to ground is, it's along which direction? Leftward direction, let's say minus V1. So velocity of B with respect to ground is V2 minus V1. V1 is velocity of B with respect to. Good, I got it. V1 is my velocity of V2 is my velocity of B. That's a good thing. Then by conservation of linear momentum, we can say that initially both the momentum were zero actually. Finally, they are having momentum. So 0 plus 0 is equals to mass of the smaller block, mass of the larger block, 8m, into it has got a velocity of minus v1, then plus mass of the smaller block m, it has got a velocity of v2 minus v1. Done. And from here, tell me what you're gonna get. 9 v2 is v1, right? Sorry, 9 v1 is equals to v2. 9 v1 equals to v2. Again, from the conservation of the work energy theorem, we can check. So gravity is doing work in the downward direction, which is positive. Work done by external plus work done by internal should be equals to K final minus K initial. Work done by external is M G into A plus work done by internal force is 0. K final is basically half 8M into this one is moving with a velocity of what? V1 square. Half M V2 minus V1 square. This is the kinetic energy final minus kinetic energy initial is 0. Have a look, minus kinetic energy initial is 0. So once you get this, then it's very simple. mg is equals to half 8m into v1 square and half m into v1 minus v2 square. v2 minus v1 square. Good. If you solve this, you're going to get the answer. v1 is g into a by 36. That's the answer. Solving this and this, you'll get this. Okay, so I will end the class here. All of you students, जिनको भी ये PPT चाहिए, they can definitely visit to my Telegram channel, which is Sourav Sir Testbook. And apart from that, मैं यहाँ पे लिख भी देता हूँ Sourav Sir Testbook. इस टेलीग्राम चैनल पे आपको इस लेक्चर का PDF मिल जाएगा. अपार्ट फ्रॉम दैट, जो भी बच्चे CSIR NET 2024 के लिए प्रिपरेशन कर रहे हो, उनके लिए बूस्टर कोर्स हैज ऑलरेडी बीन लॉन्च्ड, व्हिच इज अ वेरी वेरी इंपॉर्टेंट कोर्स, जहां पे आप लोगों को सारे के सारे थ्योरी क्लासेस डिटेल्ड फॉर्मेट में रिकॉर्डेड मिल रहे हैं. अपार्ट फ्रॉम दैट, लाइव क्लासेस में हम लोग PYQ सॉल्व कर रहे हैं. बहुत सारे मॉक टेस्ट अवेलेबल है जो बहुत ज्यादा हेल्पफुल है फॉर रिवीजन पर्पस एंड फॉर द एग्जाम प्रिपेयरिंग पर्पस. अपार्ट फ्रॉम दैट, तुम लोगों को PYQs बुक दिए जाएंगे एंड PhD मेंटरशिप प्रोग्राम ऑर्गेनाइज किया गया है, जो प्रोग्राम बहुत ही हेल्पफुल है टू डिसाइड व्हिच सब्जेक्ट टू टेक और कौन से इंस्टीट्यूट चूज करना है या इंटरव्यू में कैसे तुम अच्छा कर सकते हो. So to purchase that code, don't forget to use the promo code SOURAV Saurav to get the maximum discount. Use this promo code. ठीक है, चलो, थैंक यू वेरी मच. मैं क्लास यहाँ पे खत्म कर रहा हूँ. इफ यू हैव एनी डाउट, any question, let me know on the comment section. Thank you.